Today we're looking at section 5.5, which is the triangle inequalities and the triangle inequality theorem. To start off here, we're going to look at our two theorems involving triangle inequalities. First theorem says if one side of a triangle is longer than another side of a triangle, then the angle opposite the longer side is longer than the angle opposite the shorter side. Let's fix this here and make that larger. The angle's larger, not longer. But looking at the theorem, what we're saying here is if we look at one side compared to another, if I look at AB and BC, I know for sure that AB is greater than BC. If that's the case, then the angle opposite AB, which we look here, if I have side AB, C is opposite that. So angle C, which is opposite of AB, is greater than the angle opposite BC, which looking at BC would be angle A. So by looking at those opposites, we can compare and say that C is bigger than A. The second theorem says if one angle of a triangle is larger than another angle, then the side opposite the larger angle is longer than the side opposite the smaller angle. Same idea, we've just switched the order. So now we would say if the measure of angle C is greater than the measure of angle A, then AB is greater than BC. Now it's just kind of going that opposite direction. So it gives this relationship between the opposites. So if the angle and the side of the opposites together are bigger values, they'll be bigger than the sides and angles that match up for another pair. Now, this only goes two at a time. So I compared those two. I didn't really do anything with AC or angle B. And I could have. I could have said something about BC and AC and then had another statement about A and B. I could have had a statement about AB and AC and then had a statement about angles B and C. But we're really going to put all of these together because just by comparing two at a time, we can see that, well, we can just start listing all the angles and sides together in a triangle in order. For example, in my triangle here, eventually I'm going to list them in order from smallest to largest. But looking at it first, I know I have 6, 12, and 15. Looking at just the numbers, I know that 6 is smaller than 12. 12 is smaller than 15. 15 is bigger than 6. So I can kind of see just from those sides how they work. Now, I know, we're going from smallest to largest, that AC is the smallest side. The next biggest side is 12, so that's BC. And the largest side is 15, so that's AB. So that's going from small to large in the sides. If we take the idea for the theorem we just had, we can start looking at opposites. AC, opposite of AC is angle B. Opposite of BC is angle A. And opposite of AB is angle C. So just by looking at opposites, I see from smallest to largest is B, A, C. Now let's take a second and notice here that if I have letters AC, its opposite angle is the letter not used. BC, opposite angle, is the letter not used. AB, the opposite angle, is the letter not used.
If you're not participating in an extracurricular activity at this time, please report to the front of the school to wait for your ride.
So that can also be something we keep in mind as we go. Now, real quick, another example. This is now looking at angles first. I'm going from sides, from shortest to longest. The smallest angle is 29. So that's angle R. Opposite that is ST. The next angle is 30. That's at T. Opposite that is SR, or RS. And last is 121, our longest. That's angle S, so opposite that is RT. So from shortest to longest is those three sides. Be careful not to switch the order. Shortest to longest, longest to shortest. You could easily switch those, reverse them, and you end up with the wrong answer, even though you might have done the correct process. Okay, this last one, you're going to sketch a triangle, and if I sketch what I'm going to have here, I know I have three sides, 3, 7, 9, angle 16, 41, 123. I know already that the 3 and the 16 are going to be opposite of each other, 3 being the side, 16 being the angle. 9 and 123 are going to be opposite each other too. They're the biggest values. They should be opposite of each other. Same with the 3 and 16. Smallest values, they'll be opposite of each other. 7 and 41, well, they're going to be opposite of each other because they're the only ones left. So I know they're going to match. So now I just need to see where everything fits. I need the longest side on the bottom, so that's 9. 16 is the smallest angle, that needs to be on the left. So looking at that, 9 is the longest side. The largest angle is 123. That needs to be opposite that. That leaves angle 41 for the right side. Then I look at my sides. I have 16 and 41. 16 is a smaller angle than 41, so a smaller value should go there. That'd be the 3, leaves the 41 with the 7. There's our triangle. Longest side on the bottom, smallest angle at the left. Opposite values match up for order. Next we go to our triangle inequality theorem.
Please call activity. Fred Avila, please call activity. Thank you.
In our triangle inequality theorem, if we take what it says, the sum of the lengths of any two sides of a triangle is greater than the length of the third side, we actually get 3 statements. AB plus BC is greater than AC. This side and this side is greater than that side. Then I could say AB plus AC is greater than BC. And finally, let's see what's left. We got to put in the AB here, so it would be AC plus BC. So by this statement, we get these 3 statements. We don't want to use these all the time, though. In fact, we can even simplify this a little bit. BC is our shortest side. So we're saying here that BC is less than the 2 bigger sides added together. Well, the shortest side's always smaller than the other 2 sides added together. In fact, the shortest side's smaller than both of the sides individually added together. So this, kind of an obvious. We're not going to use that one. It's obvious. AB, for that matter, is the second shortest, or it's the middle length. Well, that's going to be smaller than the other 2 added together because, well, it's smaller than AC. So it's always going to be smaller, so that one's the obvious. It's this one we're going to use. AC is less than AB plus BC. That longest side is less than the sum of the other 2. So we're going to say the longest side is less than the sum of the other 2 sides. Now, instead of the AB, BC, and AC, this gives us for any triangle. The longest side is always less than the sum of the other 2 sides. If it works, it gives us a triangle. You know, in fact, we even know the question they're going to give us. They're going to say, do these sides form a triangle? That's the question they want. Well, then we're going to use the longest sides less than the sum of the other 2 sides. And if it works, it gives us a triangle. If it doesn't, well, it's not a triangle, and that's fine. Now, let's also look at, maybe they give us a question, what is the third side? So let's think of a scenario where they give us 2 sides, and they want to know what could be the third side. And that's using still these theorems up here, but there's a certain range we have to be in. We can't just pick any numbers. Some numbers work, but some may not. And what we're going to do here is we're going to say the difference of the 2 sides, and we're going to take the sum of the 2 sides, and we're going to put the range for that third side to be between them. So the third side is going to be between the difference and the sum. Now notice, there's no equal to. In all of these, they're all less than symbols. There's no equal to. It has to be between the range. So when they ask, if they give us 3 sides and ask if it forms a triangle, well, the longest side's less than the sum of the other 2 sides. If they give us 2 sides and say, what is the possible third side, we're going to give them an inequality within, with a range that gives us options for values. So, let's look at some examples of that. If you don't have them already, you should probably write down those rules before we go through these, because I'm not going to copy them again. We're just going to go through and solve these as we go. We look at the first one. Is it possible to construct a triangle with the given side lengths? That's our first rule. So, longest side is less than the other 2 sides, or 7 plus 5. 9 is less than 12. That's true. So yes, it does construct a triangle. 9 is the longest side. That's less than 6 plus 2. 9 is less than 8. That's not true. No, it doesn't form a triangle. 8 is less than 6 plus 2. I get 8 is less than 8. Yes, they are equal, but they are not. It's not an inequality. It's not true. It does not form a triangle. This, in fact, would give us a line, not a triangle at all. And last one, 14 is less than 11 plus 8. I get 14 is less than 19, and that is true. So that is yes. If it meets the inequality, it forms a triangle. If it doesn't, it's not a triangle. Now we look at finding the possible third side. So here they gave us two values, and we need to know what the possible third side could be. So going back to our rule,
Please remember to post your attendance. Thank you.
I'm going to take the difference of the two values, and that's going to be the lower value for my third side, or lower range. And I'm going to take the sum of the two values, so that's adding the two together. So I do that, and I get 4 and 8. So my third side has to be between 4 and 8. So to make this even easier, I'm going to write between 4 and 8 as my answer. It's going to be some number between there would form a triangle. Now, whole numbers would be 5, 6, and 7. But that's not our only options. We also have the decimals. 4.1, 4.2, 4.3. Anything between 4 and 8 that does not include 4 and 8 would be possible answers we could have. Then we have 3 minus 2 and 3 plus 2 for our range for 3 and 2. And that leaves us with 1 and 5. So for 3 and 2, our third side is any value between 1 and 5. For 8 and 9, I do 9 minus 8, 9 plus 8. Gives me 1 and 17, so it's between 1 and 17. And last, 1 and 4, 4 minus 1, 4 plus 1 leaves me with 3 and 5, so it's any value between 3 and 5. Again, they can be whole numbers, they can be decimals, as long as in this case it doesn't include 3 and 5, any value would form a triangle.